Hey, Ski Club people, if you are watching this video, come and tell me you watched the video, and I have a fun story about when my friend got a concussion while we were out snowboarding.
No way.
We didn't believe him, and therefore we messed with him for a few minutes, and then we realized, oh crap, he literally has trauma to his brain. We should stop telling him things that aren't true. So, moving on from that, we're going to graph these points on our axes, which you already conveniently have on this paper, because I live to make your life easier. So make sure that we pay attention to x, y. That x is always the first value given to us, which is the left and right, the horizontal axis. I like to start in a lighter color, and then if I'm going to be drawing like a second shape on the same graph, do like a darker color so it kind of shows up on top. So 2, 1, and up to you if you want to do colors today and make it look a little cooler. Another advice, I like to mark my 5s and my 10s. Now I know this came out a little awkward with like what printed dark and what printed light. Sorry. You can also just use graph paper. If this really bothers you, you can also just use graph paper. So I like to mark out my 5s and 10 for things like if I want to get to 5, 5, I can just jump right there. 2, 5. And then we're going to connect, which is quicker with a ruler. Then I want you to redraw this shape after you multiply every value of every point by 1. That's right, because multiplying by 1 leaves everything alone, right? So let's actually make this a bit more fun, because that would be silly. Let's multiply each of these by 2. Let's go 2. Let's multiply each of these by 2 and see what happens. So you're graphing 4 more points, double every single value you saw up here. So like 4, 2. Right, 6, 2, 10, 10. Ah. And that is why we drew just the first quadrant for this one. I got a secret that might blow your mind. And then, watch what happens if we draw these lines. From this point, through that point, down to the 0, 0. Through that point, down to the 0, 0. And it starts to kind of look 3D-y.
Wait, hold on.
You see it?
Yeah, I see it. First I need so I can act the shape of like expanding outwards.
You know, the mathematical word for expanding outward or inward, actually. That's a different kind of expansion. You're not wrong. It's just a different kind. This is like a... It happens when you go to the eye doctor.
Dilation?
Dilation
Oh, so you're dilating your shape.
is any time we take a shape and we say, all right, I want the same shape, but I want it to be different size. So essentially, we're talking scale factor here. Right? What scale factor did we just use? 2.
What makes it different from scale factors? Is it the same thing?
Yeah, dilation is just a formal. Because remember, we're back in the 8th grade textbook. We already talked about scale factor back in the 7th grade textbook. Now we're going to be doing even more. Because do you think we're going to just stop right there? Absolutely not. So now on graph paper, because you definitely got graph paper because we always get graph paper, we're going to graph these points. Nope. These points. It's bigger on this slide. And this will slow me down because I'll have to do it with you guys. We're going to make this triangle. Who what? Like the one that we're doing right now?
Yeah.
I mean, you don't really need to. This is just classwork. Now, if a problem on your homework requires you to use graph paper, yeah.
Yeah, that's
Learn
what I
that.
thought.
I mean, you're always welcome to. I mean, so if I was you, sorry, my brain glitched out because when they asked me a question, I'm coming to you. No, wait, Tommy's sitting here. If I was you, I would just in the middle of a piece of graph paper make some axes just for your classwork. Like literally, you could just label the top of this paper Chapter 6 graph stuff. Like literally, you could just label that Chapter 6 graph stuff. And then XY axes, I don't want to show you too much of mine because that'll give away what we're doing. We're going to graph this triangle. When you get done with that triangle, instead of just multiplying everything by 2, let's multiply everything by negative 2. Every single value. And I want you to make a guess of what might happen before you actually draw it all out. If we multiply everything by negative 2, everything by negative 2. Ski club people, I hope you're having fun. Actually, yeah, today's kind of, I don't know if I'd want to go skiing today or not. Yeah, it's like right on the fringe of freezing. Not necessarily the best kind of weather for it. We're going to multiply everything by negative 2. You guys, if you're one of those people that loves to label every single piece of your graph, love it. But during class, if I was you, I'd mark out the 5 to the 10. I would not spend the time necessarily numbering every single number on your axes. Or some of you are even people, where you number out your 2, 4, 6, 8, 10. Like, that's fine. You're welcome. Some of us are odd, which if you number out 1, 3, 5, that's fine. I like to number 1, then 5, then 10. Because I like to show the 1. Dang, this helped all my speed so much. So now, once you get those graphed, multiply everything by negative 2. Yeah, like then we're going to graph those and see what did happen. So we're going to draw that triangle.
okay.
Sorry, I only drew those little lines to figure out where the heck are those points, because they didn't do it on graph paper, they just did it like on axes. So then we're going to take, so like negative 6, 8 is going to become, yeah, positive 6, negative 8. Sorry, yeah, no, Joe! 12. Okay, well, okay, hold on. maybe we should just do -1 first because I don't know how big you made your graphs. Alright, up to, dude, because I looked down and I saw yours. If you multiply all of those by -2, I think you're going to be off the page potentially. Let's do -1 to start, because let's just play with the negative. Because you guys said multiplying by 1, Sasha, left everything the same. But what will multiplying by -1?
It switches. Sorry.
Oh, never mind though.
That was the hypothetical ask of like, let's investigate, not the actual shout out the answer. Guys, this does not have to be perfect. We are just playing with math and finding out what happens. Let's go -1. Sorry, my bad. I realized how big this is and it might get off of your paper. My bad. Did I already announce that if you didn't turn in your homework Friday, you can still turn it in today and it count on time?
Yeah.
Because I did not get it in math yet. Yeah, I got the other classes test screen. If you turn in your homework today, it'll count as if it was on time. Are you hunting what's happening to the shapes?
No. Yeah.
All right, one of you shouter outers. You want to start telling us what you maybe figured out after you multiplied everything by -1?
Oh, it's really weird.
Gwen, even though you left your mind here all weekend, what?
Well,
The more crap I give you about that,
Anyways.
the more you might remember in the future.
alright. So it's basically turned upside down. Not exactly, but basically.
You should get this. My pink shape was my first one. My green shape is my new one. Now wait, who just said what you just said?
Henry.
Henry, say it again.
I asked how many give it over.
Well, would it make sense that if I turn, well, okay, what do you think, what rotation do we think happened here?
180.
So would it make sense that if I spin something 180 degrees, my edges would end up well, okay. My bottom comes up here to be my top. Does it make sense that if it was flat then, it's flat now? Yeah. My left side spins around and comes over and is now my right side, but their slopes actually stay the same. Right? And then so we end up with a parallelogram, kind of. Right? We sort of end up, there's a parallelogram in there that we can see. Questions about that? So, multiplying with a negative spins us? So here's my questions that we're not going to need to investigate right now. But what if we only multiplied the x's by -1?
Wait, I know.
What if we only multiplied the y's by -1? Because we did both. You want to make a conjecture?
90 degrees.
I don't know if I agree. If just the x's got multiplied by -1? Because wouldn't that make a +5 become -5? And a +8 become -8? And really I should be pointing the other directions to facing out towards you guys. But then all the y values would stay the same.
Well, did it make a new shape?
I mean, it'd make a new shape that way. Guys, these shapes are congruent. They're the exact same shape, just pointed different directions.
Exactly.
Right? These two shapes are actually congruent. Here, let's play with this. You don't have to do it on your paper, but just to hypothesize, let's do -1 just to the x's. So if I do -1 just to the x, what does -6, 8 turn into?
6, 8.
Positive 6, 8. So there's my positive 6, 8. What's my -2, -4 turn into?
2, -4.
2, -4. My positive 6, -4.
-4, -4. I mean, -6,
-6, -4. And now my new shape would be So we did x's times -1. Is that a what? Yeah, but where did pink to blue? What did it reflect across? The y-axis. When you reflect across the y-axis, your y's actually stay the same.
Whoa.
Says if you look pink to blue, we flipped the x's. What was negative became positive. What was positive became negative. We flipped your x's, and that is a reflection across the y-axis. Because if you folded your paper, those shapes would actually line up right on top of each other. They're perfectly in the middle. And now we've got a cool little pentagram here. You guys see the pentagram? Or the pentagon. Sorry, pentagram was the Pythagoreans. It was their symbol. It's like a hexagon with a bunch of triangles. And so, yeah. All right. So this week, if you look over at the homework board, is kind of awkward because I'm trying to cover multiple, like, I would love to make it through the end of chapter 6 this week, just because I don't think we need to go slower than that. So you need 622. If you already have it, tell me that you already have it, but since I didn't put it on the board, I doubt that most of us got it. So, you got it?
I got it.
Same,
I got it.
got it? You need it?
I got it.
Okay. How about raise your hand if you need a 622? Because I laid out all my extras too, so I think I just have a bigger set. So Elsa, you got 622? Jackson, did you get 22 yet? Yeah. Alright, let's check out 22. Now, hold up. I bet you'll listen better than you read. Maybe. This shape is the result of Charlie having dilated by 3. So Charlie took an original shape and multiplied everything by 3. My bad, I misunderstood you. So what we want to do is undo Charlie's dilation to figure out what the original shape looked like. So we are undoing a multiplication by 3. How do you undo a multiplication?
Divide.
Yeah, you guys know what to do. Do that on your paper.
We basically find like the points that are plotted and then divide the x and y coordinates by 3.
Yep. Ah, correct. Sorry, this one is 4. My bad. The next one's 3. This one's 4 because they're all nice, even numbers. Thank you. Honestly, you should get a piece of candy if you want, because that was a pretty big error that if nobody noticed, we all would have been, like, real frustrated. Hey, have the confidence to point it out when somebody else makes a mistake. That'll be real important for you guys and some of your friends. Seriously, sometimes when our friends are making mistakes, they need us to tell them, hey, you're making a mistake. You might want to stop. You would just watch it. Wow, what a kind friend.
Well,
No,
Better.
I just wait.
Well, no, if they were a best friend, I'd laugh with them. If they were like an actual, if they were just a friend, I'd be like, yeah, the better.
I mean, like, who am I to judge?
You're gonna insult them every time.
So moving on, because I'm starting to have a little bit of judgment for how kind we are to each other or not. Guys, we're all just humans trying to do the best we can. Should look out for everyone pretty much equally, whether you love them or only like them. So I'm at -4, +4, right, to start, which is really nice because what are we doing to undo a multiplication by 4? We're dividing by 4, so like -4, +4. I think the new one just drops right here, -1, +1. So go ahead and keep doing this.
Or should we graph it when we gather numbers?
Yeah, so that's my B. I keep like assuming that you'll assume, yes, do it. Yeah, I know. That's why I said my bad. So for -4, well, I'm not doing anything with negatives, so I'm just,
1, -1.
yeah, 1, -1. 8, 4.
2, 4. I mean 2, 1.
This one still has some kind of fun lines. They don't feel as fun as the other one. If I do that, and I do that, this one's kind of got some fun lines. Why do I only have 2 fun lines to draw?
The other ones are disputed.
The other ones are what?
The other ones already have. They're going through each other.
Ooh, Owen, what do you mean?
Like you can't really draw a line through.
Yeah. The other lines of like dilation are already running through each other because they're like a perfect point, right? Like they're exactly XY 4 and 4, or 1 and 1, or 4 and 4, or 1 and 1. And I know I'm ignoring positive, negative, but they're on the same line. So those lines of dilation aren't as fun, in my opinion, as like what this one looks like. I feel like this one looks way more fun. All right, so here, if we were undoing our scale factor, the original scaling was ×4. What scale? Hey, some of us got this wrong, like still on this most recent mastery. What was our scale factor to go from the big shape to the small shape? From the big to the small.
4 over 1.
Nope. Scale factors can never be negative. We just talked about negatives rotate us.
So like,
Guys, you should probably write a note of this on your paper. This scale factor we just did to shrink our shape in is a scale factor of 1/4.
Oh.
If we were undoing a multiplication by 4, it's division by 4, but you don't divide. Scale factors are always multiplying. Scale factors are always multiplying. That's supposed to be an L. So it's what do we multiply by? We multiplied by 1/4 to shrink us back down. Your scale factor can never be negative. Scale factors between 0 if you want to destroy something, and infinity if you want to get as big as possible. Scale factors are between 0 and infinity. Questions on that one that we just did? Because then I only really have like one more problem that we need to do. All right, 53. We want to graph these points. -1, -1, -1, 1, 1, 2, and 2, -1. And we're going to undo Alana having gotten these points using a scale factor of 1/3. So what would undo a scale factor of 1/3? Elsa? Multiply by 3. Alright, I guess I can do it up here. Even do some fun colors up here. I think pink will show up. I don't love the line tool because it tries to make my lines straight, and like this one, it just kind of messed up. Just by the way, this is why I don't love drawing up here. All right, so Elsa said we're going to use a scale factor of 3. dilated demons or things like that. And then we draw those connection lines. Really interesting. Let's do one. This is how visual art that messes with your eyes. This is how it works.
It's all about the
Who's in
vanishing
art
point.
to know what we're talking about? If things are shrinking away, smaller until they disappear. What's it called?
Vanishing point. Is that just me?
So, humble brag. Yeah, math relates to art. Guys, dilations and understanding that stuff is nothing more than just understanding vanishing points. So here's a little sketch I did utilizing vanishing points. Because this is essentially your center of dilation. Right? So if we're dilating something coming out from the center, well, if you're on that line, it won't necessarily look as dramatic. But if everything is off of that center point, we could keep kind of dilating out and keep making bigger and bigger iterations. I'm sure you guys have seen art or videos or stuff that does this to you. Questions about our dilating. Then what happens if we start involving negatives? Does that make us smaller? No, negatives did what to us?
Flipped it.
They flipped it, right? Either reflected or rotated, but it flipped, it messed with the shape. It didn't make it smaller. Negatives perform flips or rotations. Fractions make things smaller. Any questions?
No.
Hmm?
Because it's irrational.
No, fractions. They're rational.
Oh, yeah.
Yeah, pi is irrational. All right, you can have the rest of the time to work on homework. We went faster because there's less of you today because ski club's gone. So, and today's lesson wasn't that crazy.